Ever wondered if we could live among the stars? What if it's not just a sci-fi dream, but a tangible future? As humanity sets its sights on the cosmos, the idea of establishing space colonies emerges as both a tantalizing vision and a formidable challenge. The allure of space exploration is undeniable. There's something utterly captivating about the thought of venturing into the great unknown, of setting foot on uncharted celestial bodies. But beyond the thrill of exploration lies an even greater necessity: the establishment of sustainable environments capable of supporting human life in the void of space. It's a notion that sounds straight out of a science fiction novel, yet it's a goal that's well within our reach, thanks to remarkable advancements in technology and a steely human resolve. The journey toward space colonization necessitates significant technological breakthroughs and collaborative efforts. We're talking about life support systems that can sustain human life for extended periods, efficient waste recycling, oxygen generation, and water purification systems, all vital components to ensure the habitability of a space colony. But it's not just about survival. We're looking at creating thriving communities in space, communities that are self-sufficient, that can grow their own food using advanced agricultural systems like hydroponics or aeroponics. Communities that can harness renewable energy sources like the sun for power. Communities that embrace a zero-waste philosophy, recycling waste into usable materials, and responsibly managing resources to balance the colony's needs with environmental preservation. And let's not forget healthcare. The isolated and challenging environment of space demands robust healthcare systems. We need to develop medical technologies that can address the unique health challenges posed by space travel, including microgravity, radiation exposure, and psychological stress. Indeed, the dream of space colonies is not merely a futuristic fantasy, but a tangible goal within our grasp. We stand on the cusp of a new era, one that could redefine the future of humanity. As we embark on this journey, we're not just reaching for the stars, we're planning to live among them. The first step towards this fascinating journey is selecting the right location. The Moon and Mars, our closest celestial neighbors, emerge as prime candidates for human colonization. These celestial bodies within our cosmic backyard hold the potential to become humanity's new frontier. The Moon, our closest neighbor, is rich in lunar regolith, a kind of dust that could be repurposed for construction. Its proximity to Earth also makes it a practical choice for initial colonization efforts, facilitating resource transportation and communication. Mars, on the other hand, provides a more Earth-like environment. Its day-night cycle closely matches ours, and it has potential for liquid water, a key ingredient for life as we know it. Both celestial bodies offer unique advantages, but also pose distinct challenges. As we stand on the brink of a new era of space exploration, we must carefully weigh these factors to select the most suitable location for our first space colony. Once we've found our new home, it's time to build it. Creating a livable environment in space demands substantial technological advancements. The crux of this endeavor hinges on the development of life support systems. Without robust life support, any attempt at space colonization is akin to building castles on clouds. The ultimate goal is to create a closed-loop system, a self-sustaining environment that replicates the Earth's biosphere, but on a much smaller scale. This microcosm of our planet would need to support human life for extended periods, possibly indefinitely. Imagine a system where every output is recycled back as an input, where nothing is wasted. That's the essence of a closed-loop system. It's a cyclical process that mirrors the natural world, where the waste of one process becomes the resource for another. A key component of any life support system is waste recycling. Now, this might not be the most glamorous part of space colonization, but it is one of the most vital. In the confines of a space colony, every bit of waste must be put to use. Organic waste can be composted and used to enrich soil for growing crops. Even human waste can be processed and recycled, providing a valuable source of nutrients. Next, we have oxygen generation. Just like on Earth, oxygen will be vital for life in a space colony. One way to generate oxygen is through the process of electrolysis, where electricity is used to split water into hydrogen and oxygen. Another method might involve cultivating oxygen-producing plants and algae, which would also contribute to food production and waste recycling. Water purification is another critical aspect of a life support system. Every drop of water would need to be reused over and over again. Advanced filtration systems would be required to purify and sterilize water, making it safe for human consumption. With the right technology, we can create a sustainable environment. But what about sustenance? Going grocery shopping on Earth won't be an option, so we must bring the farm to space. This means developing advanced agricultural systems that can thrive in the unique conditions of space. Imagine a high-tech greenhouse where plants grow not in soil but in nutrient-rich water or mist. This is the reality of hydroponics and aeroponics, two methods that could become the cornerstone of food production in space colonies. But cultivating crops in controlled environments brings its own set of challenges. Think about it. In a world where gravity is a fraction of what we're used to, where does water flow? How do plants know which way to grow? And when space is a premium, how can we grow enough food to support a colony? These are just a few of the hurdles we'll need to clear in our quest to become interplanetary farmers. Food and water are sorted, but how do we power up a colony in space? A space colony needs power, and lots of it. But the solution is literally shining down on us. For a community living beyond the Earth's atmosphere, the sun's limitless energy is a gift that keeps on giving. Harnessing solar power is vital for energy independence in a space colony. Solar panels convert sunlight into electricity, providing a clean, renewable source of power that's crucial for sustaining life in the great cosmic frontier. But it's not just about generation. Efficient energy storage solutions are equally important. High-capacity batteries and other advanced storage systems ensure that the lights stay on, even when the sun isn't shining. Beyond our solar panels, there's potential in the celestial bodies themselves. Imagine mining the moon or Mars for resources to generate power. It's a tantalizing prospect. Energy independence isn't just about survival, it's about sustainability and laying the groundwork for a thriving, self-sufficient community in space. With energy secured, it's crucial to keep our new home clean and resourceful. In space, nothing goes to waste, not even waste itself. Our journey into the cosmos demands a revolutionary approach to resource management. Every scrap of material, every droplet of water, every breath must be recycled, repurposed, and reused. The mantra of a space colony is simple: waste not, want not. Advanced recycling systems come into play here. They break down waste materials and transform them into something useful. Picture this. The plastic wrapper from your lunch, after undergoing a series of processes, could end up as a component of a vital tool or a part of the habitat's structure. It's the pinnacle of efficiency, an absolute necessity in a space colony. But recycling isn't the only piece of the puzzle. Responsible resource management is equally important. Mining and extraction from the celestial body we colonize must be balanced. We need to meet the colony's needs without depleting the environment. It's a delicate dance, but one we must master. With a sustainable environment and resources, the final piece of the puzzle is healthcare. Space is a harsh environment. To thrive, we need robust healthcare systems. Our journey among the stars may seem like an exciting adventure, but it's not without its unique challenges, especially when it comes to health and well-being. Imagine floating in zero gravity, surrounded by the infinite expanse of the cosmos. Sounds fascinating, right? But this microgravity environment can have profound effects on the human body. From muscle atrophy to bone density loss, the effects of living in space are still being studied and understood. Then there's the issue of radiation exposure. Outside the protective shield of Earth's atmosphere, we are exposed to higher levels of cosmic radiation, which can increase the risk of certain health conditions, including cancer. Developing technologies to shield us from this radiation is a crucial part of making space habitable for humans. Now, think about the psychological stress of living in an isolated and confined environment. Being away from Earth, from the familiar sights and sounds, can take a toll on mental health. This makes psychological support services an essential part of any space colony's healthcare system. But it's not all doom and gloom. Space also offers unique opportunities for medical research. The effects of microgravity on human physiology can provide valuable insights into how our bodies work, potentially leading to breakthroughs in medical science. Having well-equipped medical facilities is therefore a non-negotiable requirement for any space colony. These facilities need to be capable of addressing a wide range of medical issues and emergencies. Similarly, having trained medical personnel who can handle the unique challenges of space healthcare is equally vital. In essence, ensuring the health and well-being of space colonists involves a blend of advanced technology, medical expertise, and innovative research. It's about creating a healthcare system that can adapt to the unique challenges of space, while also leveraging the opportunities it presents. With these key components in place, the dream of living among the stars may not be as far-fetched as it seems. Our journey to the cosmos is not just about reaching new frontiers, It's about ensuring that we can thrive and flourish in these new environments, creating a future where the stars are not just points of light in the night sky, but places we call home. So, is space colonization just a sci-fi dream or a tangible future? We've traversed the cosmos in this discussion, exploring the key components required for establishing a space colony. The first step is selecting the right location, with the Moon and Mars standing as strong candidates due to their proximity and potential habitability. We've delved into the essential technological advancements needed, such as life support systems, efficient waste recycling, oxygen generation, and water purification systems. We've considered the importance of agriculture and food production, highlighting advanced systems like hydroponics and aeroponics. We've underscored the need for energy independence, focusing on renewable energy sources and efficient storage solutions. We've discussed the importance of waste recycling and resource management, and we've acknowledged the critical role of robust healthcare systems in such isolated and challenging environments. These efforts require collaboration, sustained investment, and technological innovation. As we embark on this journey, we're not just exploring the cosmos, we're redefining the future of humanity.